Hello everyone and welcome to a new episode of All Things IDA. In today's episode we're going to be talking how to load the debugger, start or suspend the process, set the debugger options, how to issue single stepping. All this we'll be doing in a debug loop as opposed to responding to debug events as we will see in future episodes. With that, let's get started. Okay, so the first thing we notice here is we don't have a debugger selected. Now that's something we can configure from the debugger, select debugger, and we select one of those debuggers. If you had the set default debugger selected, then you will have a debugger, but we can't make that assumption, so we have to programmatically make sure the debugger we want is selected. So we can go to dbg.hpp. This is where all the debugging functions exist, and we look at load debugger API. So load debugger API takes the debugger name and whether we're using remote debugger or not. So here, let's set up our script and say load debugger. Now I'm selecting Win32 debugger and local, so non-remote. Now those names come from here. So what are the values we can pass to the debugger? So for example, we have ARM Linux, ARM Mac, we have Win32. For example, Win32 user is for, that's the convention. So the underscore specifies whether it is remote or not. So stub is just a stub, a client for the remote debugger server and so on. WinDebug, box user, there's no remote debugging for box, for example. We don't have to specify the bitness, just specifying the prefix and IDA will fill in the rest. So to select the Win32 debugger, that's enough. And since it's local, then it will select automatically Win32 underscore user. Now let's invoke it. And check it out. So when I run the script, you'll notice now Win32 debugger will be selected. Here, local Windows debugger. If I change it to box and run it again, we have the box debugger selected. So let's switch it back to Win32. Now the second thing we want to do after we load the debugger, we want to see what to do next. Of course, if you want a single step, we need to start the process. So let's check the process state with the get process state that we've covered before and check if it's no task. So let's say state equals and then get process state, and then we can check if it's not running, then we want to run. So how do we run? There are multiple ways to start the process. Basically, we can start the process through a start process directly, or from a not running state, we can also start through run to cursor, which will run and suspend at the cursor location that we want. Let's take a look quickly at start process. So start process lets us override the pass and argument in starting directory, or if we pass null, it will take the default values that we have for the process. Here, these are the process options. We will leave them by default, so we just can call start process, it starts the process. Of course, that process will start it and run it, it will not suspend. What I want is, I want to start and suspend the process. So I will use run2 instead. So run2. Run2 takes the EA that we want to run to and suspend at. So let's use that. IDAPython.run2. And for now, for example, we cannot necessarily hard code the address. So that's important because if the process starts and we have ASLR, these addresses might shift. So it's not a good idea to actually hard code stuff. Instead, I'm gonna set my starting point to be either the entry point or main. For this example, we're trying to aim for main, but we'll do a check. If main doesn't exist, then we will use the start. So we have covered this before. So let's say EA and then INF get main. This will give us main if it exists. So if we check it here, so we do have main from the file loader. But just in case we don't have it, then we will revert to the start. Okay, now this is good enough to get started. If we put here EA and run, we should run all up to this point. And here we have it. We run suspended, and now let's stop for a second. Let's clear the screen and also take a look at the output. So this output is a bit polluted. We can basically change the configuration programmatically. So this output comes from the debugger options. For example, here in the logging, those are what dictate what are the stuff we see in the output window. And those come from set debugger options. So set debugger options API, it lets us programmatically change the logging options among other things. And it takes one of DOPT. So here DOPT, for example, segment messages, break on process start. So these debugger options are controlled both the logging options and the startup events. And even here as well are controllable. And that function, set debugger option, returns the previous value. So we want to basically capture, set the options and then reverse them back. Now I don't want most of the options, so I'm gonna disable all of them. But for this, I'm going to be using just two options: fast stepping and temporary hardware breakpoints, which map to both optimize single stepping and use hardware temporary breakpoints. So here we're gonna do this before main, so all options, and this and the other one for the optimized stepping fast step. And then we restore them after main. Like this, if we break prematurely from the main function, then we make sure we have them reverted back again. So here we set the old options. Okay, so now it's important to mention something. When we say run to will execute quickly. It doesn't mean that that will be blocking. So it is asynchronous. And so we have to be careful. We can't just say run to, step into, and so on. We can't keep doing those because we have to wait for every debugger action to terminate. So just by saying run to and main basically is about to finish, that's it. And then it will restore the old options. So what happens is those lines will execute so fast that by the time the debugger starts and the process starts running, the old options are restored. So I'm not going to be able to test this right now. We'll have to cover one more thing: how to wait for the actions we issued, how to wait for them to finish. So now to wait for events, we are now going to cover one more concept. So the next API we're going to be covering is a wait for next event. And this is important. We're going to be using this in our debug loop. Wait for next event, or let's say if you're using Windows API, it should be similar to wait for debug event in Win32, for example. And that API is similar in IDA that will wait for the debug events. So we issue the run to, we have to wait for it. So wait for next event takes a flag here, what to wait for. And that flag can be basically can also issue an action. So we'll see what are the values we can pass here. Now wait for next event returns two sets of return values. If the return value is positive, then we get an event ID. If it's negative, we get one of those debug event codes. So for the debug event codes, these are just a couple of them. So basically either we timed out or there's some error, could be, let's say, remote debugging, then network error, or the process exited and therefore we are no longer waiting. So we'll have to check for either the negative values or the positive values. So if it's negative, this is could be timeout if we specify timeout or -1. So it will not time out. Then we will have either like process does not exist or some other error. And the other things is if it's successful, then whatever caused the debugger to suspend, then we get the debug event code. So debug event codes are defined in idd.hpp. And these are all the debug events that IDA supports. So let's search. So here, all the event IDs. We have, for example, single stepping. So if you're waiting for a debug event, we might get a single step, a breakpoint, process attached, and so on. Now, let's look at what are the wait for flags here. So we have here, one is wait for suspend, for example. So WFNE, suspend. That will tell us wait until suspension. Now we can also pass the flag continue to also resume from an event. So every time now we're gonna do, for example, a single step, we're gonna issue a single step and then let the process continue and also wait for it to be suspended. So we're gonna be passing two flags. But for now, for just the run to, we wanna wait for suspension alone. So let's get the code of that wait for next event, no timeout, and let's just wait for suspension. Now, if we have a negative value, let's just break out of the loop some exceptional error. Since we're not waiting for timeout, there's a problem here. We cannot continue with our logic. So here let's return, and here let's return true. Okay, now because we're waiting, then main will basically not return until really we succeeded here. So the debugger option we set previously will be respected. So let's test it out here. And here we go. We don't have all those messages, logging messages. The process is suspended and the script finished running just because we waited for it. Now let's start issuing single step. So to do single steps, we have to go to again debug.hpp and look at step into. So step into will issue a single step, but again, this is asynchronous and it will not block. So we'll have to also wait for it. Let's do 10 steps from the suspend state that we started with. So let's take that suggestion, looks good. So run to will run and suspend at main, and then we were gonna start a loop, and here we're gonna say step into. So from a suspended state, we're gonna request to step into, and then let the process continue, and we wait for it a limited time. If we get an error, we return an error. Otherwise, we will display the event what is the EA at that event. For that, we'll have to cover the getDebug event API as well. The getDebug event, and like the Windows version, it gives us a debug event. The debug event will have event code, and then based on the event code, we will have different information we can access. It's similar in IDA. We call getDebug event, gives us a debug event object. Debug event object defined in idd.hpp will contain process ID, thread ID, EA, and the EA of the event, and the event ID. So event IDs are one of those event IDs, single stepping, exception, and so on. So let's test, continue here. So let's get the debug event. And we should be expecting a step event. So here, step, and let's then display the event address. So stepped into, again, just for your information, I'm using Copilot. It doesn't always give me the best suggestions. And here, if we don't have, let's say, a step event, maybe we want to fine tune our script and so on, I'm gonna simply go fail to step into, let's say, the event, let's say, the event ID that we got, for example. Okay, let's test it out now. First, let's stop that process, since our logic is assuming we are starting from no state. We will tune it at the end to make sure it will, if we were in a running state, we'll issue a suspend and wait for the suspend, then continue single stepping, for example. Okay, let's just fix it correctly. Here our event ID is a method based on the actual debug event objects. We have event ID as a function. So now we should be good to go. Okay, here it is. We have single step 10 times. It just so happened that the 10th time is entering the API from here. Let's cover one more case here now, which is if it is already suspended, let's say, we don't need to do anything. Now, if it was not suspended, so here it's gonna be, it's running. So these states run. In that case, we will just, really it's up to us what we want to do. I'm gonna simply issue a suspend and wait for the suspend to finish. Therefore, however I am at that state here, the assumption is that we are now suspended. So here, if it was running, we're gonna simply say suspend process. Okay, so I'm not gonna run the script in a resting state. Instead, I'm gonna let the process run. Now that process is just instructed to play a WAV file. This utility can play WAV files. That WAV file is 20 seconds long, so this will give us a chance to actually run the script and interrupt it midway. So let's just add some debug messages before. Let's say print, process is already running, suspending it. Here let's just say something like print, process is already suspended, for example, is already suspended. Nothing to do. So now to test this, we will simply start manually, assume that our process was already running, and we run the script afterwards. It will it will detect the process state to be running, and it will issue a suspend, wait for it. Once it's done, it will just do 10 steps and return. Let's also just take the error messages here and just display in the case of error. Okay, so let's run the process and test that case. So here it's running. I have enough time to run the script after the fact. So here we can see process is running, suspending it, suspend finished. We entered into the stepping stage and we are stepping many times. Now between every single step after we get the suspension event, we can disassemble, we can read the memory, we can add breakpoints, decompile, anything we want. And these are things we will be using in the future to do, let's say, an unpacker, for example. Now let's just exit after we do the number of steps. So to do that, we will have to use the exit process API. So we can also issue an exit process that will forcefully terminate the process for us. So here let's go back to no task and issue an exit process, and also we want to wait for it the same way. And if we check the code, the code, we should also have the event of process exit. So if we check for the events, we should get process exited event as well. We can test it here. If, for example, code equals process exited, we can just display that we actually issued that. Okay. Let's test the whole script now. Starting from no task, start the process, single step 10 times and terminate. That's it. So here, all those steps and the termination. So let's quickly recap what we did today. We learned how to load the debugger programmatically, how to handle the process states, and based on different process starting state, we can start a debugging session. If we weren't in a debugging state at all, I chose to start the process using run2 because I don't have any breakpoints. So I want to start in a suspended state. If I was in a suspended state, there's nothing to be done. If I'm in a running state, I'm gonna issue a suspend and wait for it. Then the actual main logic that I want to do is single step 10 times, and along the way I might inspect things and so on. So we issue a step and then we wait for the event, make sure we continue the process after we request the step into. Then we let it resume and wait for it to be suspended, wait unlimited time, and then if we have an error of some sort, we abort the script. Otherwise, we get the full debug event. We know we're expecting a step event. Now, as I said, we could be doing a single step, and the suspension case could be something else, not necessarily a step. It could be an exception, or DLL has been loaded, and so on. So in this specific example, I'm keeping it simple. So I'm expecting no exceptions. I'm issuing a step. I expect a step event. Display the address of the event, and then I'm forcefully terminating the process and returning. So this basically puts it all together. This logic is good enough for us to do something useful next time. So that's it for today. I hope you found this episode useful, and stay tuned for future episodes where we will continue covering more debugging APIs such as breakpoints, thread enumeration, and all the stuff that remain in the dbg.hpp file. Thank you and see you next time.